Respected panelists, faculty member, fellow researchers, and audience, I bid you a pleasant morning. Today, I'm here as the primary presenter of our paper, which was co-authored by myself, Mohammad Burhanuddin, Professor A.K.M. Mujahidul Islam, Professor Salikul Islam, and Dr. Shakur Satudda of United International University, Bangladesh. Our paper follows the structure outlined here, beginning with an introduction, followed by a literature review, a methodology section, an architecture and dashboard section, and ends with the conclusion for the paper. Coronaviruses are a family of viruses. The current pandemic of respiratory illnesses is being caused by a coronavirus identified in 2019, SARS-CoV-2. As of date of writing this paper on June 6, 2021, approximately 173 million people worldwide have been infected, with 809,000 cases reported from Bangladesh alone. To combat this widespread occurrence, we believe that wearable can play a critical role in effectively reducing the risk of viral disease spread. Accordingly, the capabilities of IoT devices were investigated to aid in the early detection of symptoms, as wearable IoT devices can be used in conjunction with a network of existing devices, such as face mask detection system and thermal infrared camera system. The lockdown proposed by Bangladesh governing bodies has been devastating for businesses, as complying with such regulations has required factories across the country to remain closed. The RMG sector is one such sector which has been particularly hit hard. The ready-made garments industry is one of the largest revenue generator in Bangladesh, accounting for approximately 84% of total revenue. However, as a result of the shutdown, the RMG sector revenue fell by 2.99% or $15.54 billion. Additionally, this sector employs 4 million people, indicating that controlling such a large population is not an easy task for the industry. We evaluated and listed the symptoms associated with coronaviruses types that are harmful to humans, as you can see on the table on the right, and we can see that fever is the only symptom that is associated with temperature and can be measured with a sensor. Additionally, our background research revealed that wearables are one of the most frequently recommended methods of identifying and tracking COVID-19, as we will discuss further in the literature review section of this presentation. We have compiled few papers here that we have used to justify our paper. Morales Narvis E. et al. Discusses the importance of biosensing devices in details, as well as how time-consuming the various testing methods are for taking faster actions. Additionally, this paper discusses how the Internet of Things can be used in conjunction with biotechnological organizations to facilitate data sharing and response in order to contain and slow the spread of an outbreak. Kuerji et al. Developed a system that collects data from embedded activity trackers and self-reporting symptoms via a smartphone application. According to Kuer's finding, when compared to using only symptoms, wearables such as smartphones, smartwatches, and activity trackers significantly aid in the prediction and identification of symptomatic individuals in real time. Next is the methodology. These are the strategies we use to construct our paper. We developed a data collection technique that will enable us to integrate our wristbands with existing systems, such as face mask detection and infrared temperature sensors. We use Proteus design software to simulate our wristband design and determine its sustainability for data collection. Employers can access this data through a web portal dashboard. We will discuss the dashboard later in the presentation. Wearables play a critical role in this paper as we discuss how they will be designed and evaluated to work with the previously mentioned system. Now, the architecture and dashboard section. Here we discussed in detail how our wristbands are integrated into the existing architecture and the communication methods we use to accomplish this. The diagram on the right shows our sensors that includes attendance system, face mask detection, and infrared temperature camera sensors, and our wristbands. The wristbands communicate via Bluetooth and the rest communicate via LAN cables. We use an edge server for primary data storage and processing, and a cloud server for data backup and remote access from anywhere outside the premises via the internet. The dashboard is used to monitor and report to administrators and employers. The table on the right illustrates the different types of data generated by each system and how they interact. Each wearer must punch in his or her attendance using their ID cards upon entering the premises. It determines whether or not a person or worker who has just checked in is wearing a mask, as well as their body temperature before allowing them to enter the premises via the face mask detection system and infrared thermal cameras. Additionally, the employer ID serves as the wearer's unique identifier on and off premises, facilitating data synchronization when the wearer leaves the work environment, and the vital signs can be monitored and synced with the system upon their return. The system readings can assist administrators in determining whether or not to quarantine a person. This is the schematic diagram created with Proteus design software. On the left of the design for the wristbands, which includes an off-the-shelf hardware heartbeat sensor and a temperature sensor. On the right is the simulation test bench that we use to check our system for any flaws that could jeopardize our data collection and use of circuitry flaws. This is the administrator dashboard from which they can track and monitor the employees. We can configure this alert system's threshold for notifying us about each users. For instance, if a particular user is found to be not wearing face masks approximately 70% of the time upon arrival in the premises, and his or her temperature is 36 degrees Celsius, but his heart rate is significantly higher than average, 90 beats per minute, the system can display a red warning sign in the risk column of the attendance panel on the dashboard. The management can take the appropriate decision regarding the employee's isolation or quarantine. In this section, we describe our wristband design. We designed our wearables with an Arduino Nano small form factor in mind. This ensures that the wearable wristbands are small and lightweight enough to accommodate a reasonable battery size when remaining comfortable to wear. The wearable's total cost is approximately 2,200 Bangladeshi taka or $25. Next is the findings that we have generated using the system analysis tool on Proteus software. The diagram on the bottom left shows the healthy, non-infected person as indicated by the lower temperature and steady normal heartbeats. That is indicated by the width of the green line and the height of the red line. The diagram on the bottom right illustrates the reading of an infected person as indicated by the elevated temperature, which is also indicated by the height of the red line and the width of the green line, which indicates elevated heartbeat, which can also indicate a decrease in SpO2 saturation, as the heart will have to work harder to meet the decreased oxygen demand. Conclusion. The simulation conducted in Proteus software validates our expectations. However, the sensors used were purely demonstrations. The system's future development would prefer to incorporate industry standard sensors to increase system longevity and data collection accuracy. Additionally, this will enable large-scale industry use of the proposed system. Another potential enhancement is the addition of gyroscope and accelerometers, which will enable us to detect users' activity and distinguish between increase in body temperature and heart rate during exercises and rest. The paper's future objective includes the addition of machine learning. Machine learning has propelled data analysis to the forefront, providing precise predictions with a minuscule margin of error and assisting the autonomous reporting dashboard. Thank you so much, everyone. If there are any questions, we'll appreciate